Hi, in this lesson, we'll take a look at instances of classes. Let's get started. In lesson 1.2, we briefly discussed that string and char are different types. Char belongs to the primitive type, as do Boolean, double, and int values, while string is considered a reference type. To recap, there are several big differences between those types. Primitive types are considered the building blocks of programming languages, while reference types are types that have been created by programmers using those primitive types. String, for example, is a variable type that was created using char variable types and has its own functionality that has been created by programmers. In lesson 1.2, we said we would return to this concept in further detail. In this lesson, we will discuss how reference types are created and how they are used in programming. The basic principle of reference types is that they hold references to something called objects, which can be accessed by programmers from memory. Objects are variables of user-defined data types. Just as we initialize and declare primitive types, reference types are also declared and initialized. The initialized form of a reference type is referred to as an object. It's essential to understand that objects consist of a particular state and behavior. We are going to explore a specific example to better understand this idea. Let's say that this rectangle is an object. In order for this to be a rectangle object, it needs to have some attributes or characteristics that provide us with information about the object. In this case, the attributes that we expect the rectangle to have are width and height. A user has defined some information about this rectangle that allows us to store that information. Since this rectangle is an object, it must have a state and a behavior. The state of an object is the data that is associated with the object. In this case, the data associated with the rectangle object is that it has a width of 20 and a height of 8. The behavior of a given object is the actions that can be performed on the object. Often, the behaviors that can be performed on an object relate directly to the state of the object. In this case, actions such as determining the area or the perimeter of the rectangle rely on the existence of a width and a height. Here we have another rectangle created with the same predefined information. This is a separate rectangle, but also contains information about its width and height, and also has a behavior that allows us to determine the area and perimeter of the rectangle. If both are rectangle objects, they should have many of the same behaviors and the same types of state, but not necessarily the same state values. In order to create a rectangle object in the first place, we must create a rectangle class. A class is a template that holds information about what a class object's state and behavior can be, and how they can be used in programs. To create a rectangle object, we first need to create a rectangle class. In this class, we need to establish and set the rules for what each rectangle object is capable of storing as its state, and what actions it can take. For this rectangle class, we are declaring that every rectangle must have a width and height, and we are able to compute the area and perimeter. A rectangle cannot be created unless it has a width and a height. We can think about the class as the unfilled template of an object, and the object itself as the filled version of the template. The skeleton or framework is the class containing the specifications, while the object is the actual implementation of that framework. Each rectangle that is created from the rectangle class has its own attributes and exists separately from the other rectangle objects. We refer to objects as instances of the class that they belong to, because they are each a separate entity from other objects of the same class. The use of objects in programming is referred to as object-oriented programming. We will continue to learn more about the principles of object-oriented programming throughout the course. Now that you've learned about classes and objects, let's get some practice using them in the CodeHS editor.